Alright, time for another DraftPhysics.com, debatephysics.com also. Video presentation. So continuing this series of videos about Professor Dave, a rather popular YouTube science presenter. Again, arrogant, dogmatic. They say they've completed this discovery, and they've proven their case, and the trial has never been conducted in any kind of fair and rational manner. It's just been a kangaroo court, so to speak, where they as a group decide what the truth is, and they just tell the ignorant dumbasses what they are to believe. And it's all under evidenced mushy wooey nonsense, and it's easy to see the contradictions and the places where it makes no sense at all, and they don't care. So they have the formula 1/2 mv squared. Absolutely no evidence indicating it takes 25 times the fuel to move something 5 times as fast, or that something going 5 times as fast has 25 times the ability to do work. No evidence, zero. And it completely contradicts Newton's third law, which is a momentum law, which basically says momentum, force, doesn't matter, same thing. Energy, momentum, force, pressure, weight, they're all the same thing. It's all just mv. How much mass is it and how much is it moving? And the question is how can it behave? So the simple argument I'd make to you is that the force, the little tiny discrete stuff moving the speed of light, doesn't hit something and give it its momentum. It shares its momentum with the object. So it has a little tiny m and a very large v, and it shares that with whatever it hits, like an electron. And so it ends up with a bigger m and a smaller v, and that's it. But it shares, it sticks. And then in other cases where you have an elephant stepping on a mouse or something, it doesn't share. Okay, the elephant basically gives away some of its momentum to the mouse. It transfers it. So that's all that can really happen. So force sticks, shares its momentum. Big objects usually transfer what they have. So I think the only way to really say this is the force is the currency, it's the money, and the matter can collect money. The force still has a lot of it. The force is still doing a lot of commerce. But some of the money is in the hands of the matter. And it's doing transfers with the force. Yeah, I think that's good enough. All right, so this one's going to be on Hooke's law and harmonic motion. And I guess the important part is Hooke's law, which is basically a law that's the same as the law of the lever, which basically says, twice the force, twice the weight, 3 times the weight, 3 times the force, 3 times the weight. And there's no room for kinetic energy anywhere in Hooke's law. All right, so get to it, I suppose. I'll hit the button.
Professor Dave here. Let's discuss simple harmonic motion.
So there's nothing simple. That's what they call it, simple harmonic motion. But, obviously, the real universe is doing billions of calculations and interactions, trillions, gazillions, in every second that we contemplate or consider or absorb. So we are so distant from the speed of the actual universe.
He knows a lot of...
The actual universe is there's only one universe. It's the force bits interacting with electrons and protons. And everything I'm doing now had to happen there first. That stuff did it. I didn't do it. The real universe is producing me. And we're just existing in some very slow, big part of what that universe can produce. But the real universe isn't stars and planets and moons. The real universe is space, empty space. That's it, positions in space, electrons, protons, and the force. fact. Will be proven someday. Someday, all these physicists will be preaching this instead because it's the truth.
About the science stuff, Professor Dave explains.
Jerk face. He actually has a jerky face.
Sometimes when we examine the motion of an object, it will involve a single action, like a rock falling from a...
So, of course, it's not a single action. The force never disappears, never stops moving. So that single action will lead to other actions that will cause other things to happen. A cow will fall down 3 miles away because the ground vibrated just the right amount and tipped the cow over. All kinds of things will still happen. The force never dies, never stops, never discontinues its voyage. It is forever. It has a forever history.
Cliff down to the ground. This will probably just happen one time, after which the rock will remain at rest.
Yes, but it gave away all of its momentum, its force. The force that was pushing its electrons and protons is now pushing the electrons and protons of the ground and causing motion in the ground. Just a fact. All right, some motions involve a repeated action. Now, the repeated action is clearly just this idea that you can, oscillate or create a force that stays in the system. So the force can't escape, and all it can do is reverse direction.
But some motion is periodic, meaning repeated, like the motion of the pendulum on a grandfather clock, or the vibration of a spring. We will refer to this kind of motion as simple harmonic motion.
Right, so it just, there's no such category. It's all motion is understood to be conserved, that is trapped or not trapped. So that's it. So the clear understanding is you can create systems like circles and different things where the energy is trapped or not trapped. The ideal flywheel, for example, could just trap motion for ever. You could put one in space and have a perfect bearing. You won't even need a perfect bearing if you're spinning in the right conditions. It's almost like it will spin forever. And that's it. There's no, you understand that energy can be taken, that motion, that momentum. You just bang something into it and it will collect some of that motion. So we know it's just trapped.
Say we have a spring that is attached to some stationary surface, and on the other end of the spring there is a block of a particular mass. If we pull this block...
Right, so this example, frankly, the horizontal one, they have to say, well, imagine that it's a non-frictional surface. So why bother? Just tip it upside down, do the gravity thing. And it works just as well. The gravity not producing friction, but storing energy works better.
So as to expand the spring, and then we release the block, it will vibrate back and forth between more compressed and less compressed states.
Yes, so the energy you put in doesn't escape the system. It's stuck in the system. So the system just keeps pushing, and that push causes compression. Then the compression now can expand, so it expands when it's given the, when it's done compressing, it expands. And it just keeps oscillating between those two conditions. And obviously in our real world, it's dissipated in motion in the atmosphere, and the metal gets hot, and so the energy dissipates out of the system. But theoretically, done in conditions where there is no rubbing against it in any way and none of the energy can escape, yes, the energy is trapped.
If we assume that the surface of motion is completely frictionless, then the elastic potential energy reaches a maximum when the spring is most or least compressed.
So again, talking about potential energy and kinetic energy, when obviously the energy is in the condition of electrons and protons being pulled apart, and that's the real rubber band here. And you're just saying, if I pull the magnets apart, they attract, and if I pull, and that's all you're doing. You're just saying, if I put motion into it, the motion can't leave until there's something to sink it, to something to pull it out, something to rub up against it.
and the block is changing direction, while kinetic energy is at a maximum when the block is right in the middle and moving the fastest. If we were to graph the position...
So, of course, in the middle is the fastest because that's going to be the place where it's going to overshoot. So that's just saying I have this much energy, that's the peak. And now what happens to that energy? Well, it keeps going until some other system, the other side of the system, absorbs it, and now it'll push back and blah, blah, blah.
Position of the block against time, it would display sinusoidal behavior.
Well, so what? Yes, if you draw it this way, it will. But all it's really doing is oscillating between two conditions. So, you can draw it all kinds of different ways. And obviously, that's your choice to say it has something to do with this bending line when it's really not doing any kind of bending line thing.
Just like a trigonometric sine function, where the block continues to occupy the same positions over a particular period of time, which is why we call this periodic motion.
Right, and the word periodic ought to mean something in the sense of they don't use it much in their physics. And obviously you could just say there's a period associated with photons. You could always call anything they call a wavelength or a frequency, you could always just turn it into a period between events. And that logic works so much better because that makes it understandable that, to add energy to a system, the system has to be moving in the same direction. So if you want to add energy to a pendulum, you have to hit it when it's going the way you're going. Your energy's going. And if you want to take energy out of a system like a pendulum, well, then you hit it when it's coming towards you. It's not that hard to figure this out.
X equals 0 at the equilibrium position of the block, where it sat before we pulled it. And assuming 0 friction, the block will oscillate between positive X and negative X indefinitely.
Yes, two conditions that store energy in the sense that stretching a spring pulls the electrons and protons, compressing the spring pulls the electrons and protons out of position. And either one of those conditions, if freed of the condition causing the compression, will expand back to their original condition. So both will store a condition that has the ability to be restored to some previous condition because of the circumstantial change you've made in the arrangement of the electrons and protons.
In reality, frictional forces will dampen the spring's activity, and it will eventually come to a stop. But for many systems, an ideal mass spring system will be a decent approximation for a real one.
I don't know what that even means. An ideal one will be a decent approximation of a real one. I don't know, it really won't. But anyway, continuing. Different springs have different properties. Well, there you go. And one of the important properties is, again, take a pause. All right, I was saying, so the different properties, you have to understand that the spring when oscillating, so he doesn't really have to connect a weight to it, doesn't have to have it connected to a surface. You could just take a spring and compress it and then throw it in the air and it would oscillate back and forth. So it would do that in space too. So you don't really need to connect it to anything to see the fact that it's just going to oscillate between the two storage conditions. The storage of being overstretched, the storage of being overcompressed. That's it. And so it's the same thing as gravity. So you can also oscillate something in gravity by just pushing it up in the gravity and then it goes down into the gravity and then compresses something that can just restore the energy, a spring, for example. And it will oscillate. Pendulum is even better, right? Because you don't need the spring to make it oscillate. So you're just taking the energy, pushing it up against gravity, storage. Gravity gives you back the energy back at neutral. You're just pushing it back up into storage again. So it's the same storage mechanism in the sense that you're fighting gravity and then you're going to fall in the gravity and you have a limited falling distance and it just keeps oscillating between up against gravity over here and up against gravity over here, which are the same things. It's the same mechanism, gravity. And how long you're going to allow it to fall, and that's it. It's going to fall the same distance, at the same time. All right. So, but the point is if springs are going to give energy to something, that is, you're going to transfer the energy to something else. The idea is the slighter the object you put in front of a spring's expansion, the less of the energy you're going to be able to get into that object, because the spring gives the object a much higher velocity, meaning the spring is moving at a high velocity. When the other thing leaves the spring, it's still moving at a high velocity, which means it still has a lot of energy in it, and so it will continue to wobble, indicating it didn't give away all the energy. But if it moves something slow, then its spring is moving very slowly when the object leaves the spring, which means it has very little energy left in it, and so it gave more of its energy to the object. So heavy things in front of a spring, the spring will give them a high percentage of the potential, the stored energy. Light things, it'll give them a much smaller percentage of the stored energy. So this is something they don't understand, and they think they can do spring experiments and not pay any attention to how heavy the object is they're pushing with the spring, when they have to pay attention, because it's not going to be able to convert the energy from one object, from the spring to the object, as efficiently.
Of course, every spring is different. Some are loose, like a slinky, and some are stiff, like the spring that launches a pinball into play. This factor is represented by the spring constant K, which will be unique to a particular spring. The force that a spring can exert is equal to negative K times the displacement of the object it acts upon. And this relationship is called Hooke's law.
Good. All right, so I'll be back. All right, so the rule is that the spring basically proportionally adds energy based on the compression. So it basically stores the compression over the entire length of the spring, and the distance is proportional. So you could make a scale out of almost any spring, and depending on the more coils, the more accurate it's going to be, the more little differentials it can be, make, and the stiffer the spring or the fewer the coils, the less accurate it's probably going to be. But the general rule is, 1 unit of weight, 1 unit of compression, 2 units of weight, 2 units of compression, 3 units of weight, 3. So basically you can just mark the scale quite easily and it works. And I guess the same rule holds for a coiled spring, one that's coiled on itself, in the sense that the length gets shorter and longer proportionally. All right.
The negative sign indicates that the force of the spring is always opposite the direction of the movement of the object. When the object...
So that's kind of weird to say, isn't it? The force of the spring, the fact that it's pushing in the opposite direction, well, yeah. But the movement of the spring is in the same direction, the compression.
compresses the spring, it will push out. And when the object stretches the spring, it will pull in. In both cases, the spring is attempting to move the object back.
So obviously when it's pushing out, it's not pulling in at the same time. So it's not until it's gotten to its neutral condition, the condition it wants to be in, and then you're re-expanding it, which is now the electrons and protons are back where they want to be, and now you're going to sit there and push them back into a condition they don't want to be in. So you're just taking them and moving them to the right and saying they're in a condition they don't want to be in, and then to the left they're in a condition they don't want to be in, and this is the one they're going to always come back to if they can. If you haven't pulled that too hard or you haven't broken the alignment of the electrons, then they're going to spring back to the middle condition. But it's kind of silly to worry about the directional part.
To its equilibrium position, which is why the force applied by the spring can be called a restoring force. The units on a spring constant will be newtons per meter, so that when you multiply by some distance x, you get the force that must be applied to compress that spring that far.
And really it's just weight. So you're just measuring something's weight, and that's all it ever comes down to, is that would make anything simple as to everybody understand. You're just talking about all forces are weights, and you can have a constant force weight, like 9.8 meters per second, to be a constant weight, or you're going to have a weight that is impulse, and that is it declines as it gives away its energy. It's momentum. But that's all momentum is weight. Mass times a velocity. Your mass without a velocity doesn't weigh anything. Your mass with a velocity, 1 mile an hour, will weigh your weight. So you'll weigh your weight when your mass is moving 1 mile an hour. Approximately.
Let's also note that the elastic potential energy of a spring will be equal to 1/2 kx squared.
So this is bullshit. So they just made this up. There's absolutely no reason to believe it. The momentum will be just the kx part that he showed. There's no 1/2 kx squared nonsense. There's no evidence that anything has these joules of energy. So they'll never collect the energy. They'll say it has energy. They'll say it has this many joules. They'll never collect it, never prove it. So it's just bullshit religion. It's just dogmatic statement. Believe this like you believe in a Holy Ghost or a Messiah or whatever. It's just a religious statement. This is just saying Jesus said or Jesus did or the Jesus formula. It's just religious dogma. No evidence supporting its existence. No credible evidence. No scientifically credible evidence.
Where k is the spring constant and x is the distance it is stretched or compressed. If at equilibrium...
So it's just no point in doing this. The momentum will be a number, just like the exhaust coming out of a rocket. The momentum number says 150. The kinetic energy number says 150,000. Okay, that's all. And what does the rocket ship move? The 150 momentum or the 150,000? Well, the rocket ship's a big, giant, heavy thing. It'll never get the kinetic energy, so it won't even come close to having the same kinetic energy, but it will have exactly the same momentum. So again, the momentum will always work. The kinetic energy, when the masses are different, will always fail.
The distance is 0, so it has 0 elastic potential energy. And the maximum elastic potential energy will occur at the maximum distance from this point on either side of the oscillation.
So whatever that maximum means, right? So there's a point where the spring constant, the Hooke's law, fails. And that is when you compress the spring beyond it doing proportionality anymore, or stretched it where it's permanently broken, permanently stretched.
This expression looks similar to the expression for kinetic energy.
And just made up. Again, it looks like no evidence. There's just no evidence this actually has anything to do with reality. No experimental evidence. This says 25 times the force, the 5 times the, that somehow if you make something go 5 times as fast, you're going to get 25 times the work out of it. Or it takes 25 times the fuel to make it go 5 times as fast. Now, none of that happens, and it clearly isn't Hooke's law. So Hooke's law said nothing about this crap, because clearly this is saying, 1 pound is this much energy, 2 pounds is 4 times the energy. So it's saying that, putting 1 pound on the scale, 1 unit of energy. Putting 2 pounds on the scale, 4 units of energy. Now, Hooke's law doesn't say that. And clearly it wouldn't oscillate. So it's just bullshit. Absolute nonsense.
Which is convenient, since
it creates contradictions all over the place. It isn't consistent with the law of the lever. It violates Hooke's law, which he just mentioned. This isn't Hooke's law.
the two will interchange as the mass oscillates. A pendulum also displays periodic motion, since it swings back and forth between the same two positions. Although this involves gravitational potential energy rather than elastic potential energy.
Well, obviously gravitational is so kind of elastic, right, in the sense that you're just talking about gaining energy from free falling and losing energy by going up against gravity. So you move against gravity, you lose your energy. You go with gravity, you gain energy. So going against a stream, going upstream, you need a motor to take you upstream. And then obviously you can gain that same energy back again going down the stream. And you can put that back in the motor and go up the stream, and then you go free down the stream, and you can just keep going back and forth.
And we will look at this behavior next. Let's check comprehension.
Let's not. So obviously he's not going to do it. He's not going to do the silly. He's doing a Newton's equation, not a 1/2 mv squared equation. Because if he tried to do a 1/2 mv squared one, he's not going to get a rational and correct answer. It's going to be bullshit. So just bullshit again. So you just told us it's 1/2 mv squared, kx squared. Why don't you do that equation? Bullshitter. All right, so enough of that video. So I guess we'll do a second one, since we do have the time. Alright, so in this video titled Conservation of Energy, False Springs and Pendulums, he announced it by saying, let's talk about conservation of energy. So obviously, as I've stated, there's no consistency to the conservation of kinetic energy. Professor Lewin said, nature can finagle. No, nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Momentum is conserved. Kinetic energy is not. Momentum is energy. Kinetic energy is a fable. A Leibnizian religion. It's a religious doctrine. It is not a proven scientific investigated fact. It's rubbish.
We now know about kinetic and potential energy, and we know that these quantities can be altered as an object moves, like the way potential energy is converted into kinetic energy when an object experiences free.
So again, it's just nonsense. It's being pushed by a force, okay, and it's collecting the force. You could just watch the rock collecting it. There's more stuff hitting it from the top than it's hitting it from the bottom. It's collecting it, collecting it, collecting it. The more bits of matter it has, the more energy it will collect, the more force pushing down. And when it hits the ground says, how much force pushing down do you have? How many little bits, little arrows pushing down do you have? Big things collected lots of arrows, little things, light things, things with very few electrons and protons didn't collect too many arrows. That's all there is to this, and they're just made up this fable. It's all nonsense and gibberish, and I don't know why you people believe this crap. I just don't understand how you could be literate, have some knowledge of the world, and believe crap. Pull forces, magical pullness, just crap.
Fall towards the ground. But energy can be transformed in a variety of other ways.
So it doesn't get transformed, it gets transferred. So the energy is always in the same form, little bits pushing matter, or little bits going the speed of light. That's it. It's only two ways you can collect force, is that a matter is carrying it, or you get hit by the force itself like a photon.
As well. So we must learn about all the kinds of energy and how they can transform from one to another.
So they're not different forms of energy or kinds of energy. It's always the same thing, how much mass is moving. So when you have friction, you roll something on a surface and it bangs into the surface and it vibrates the surface. All of that motion got taken away from the thing moving. You're just transferring the little arrows from the thing that has a bunch of them to stuff that didn't have a bunch of them, and now they do. That's it.
We also must understand that while energy can change forms, the total energy of a closed system will always be conserved.
Right, the total energy of the universe is always conserved, and in pockets you have to conserve it. But I mean, it doesn't change anything to understand that if there's something going this way somewhere, there's something else going that way somewhere else. So it does have to balance out because the universe has every indication of being balanced. Symmetrical.
That is to say, there will always be conservation of energy.
Right, so if somebody is in space and they have a baseball in their hand and they can throw the baseball, they create motion that way by throwing it that way, and they end up moving that way. Because all they're doing is taking the system that exists and they're saying, I'm going to release some arrows going that way. And now, obviously, I had a balance that was keeping me here. Well, I'm not going to stay here anymore because now I gave away that way, and now I have more this way, so I'm going to go this way. Not complicated at all. So everything could be just looked at as, in real space, everything has these little arrows stuck to it. And yeah, we can't tell who's got, like, we could be going 1,000 miles an hour this way and something else is going 500 miles an hour that way, and it looks like blah, 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 it's going 500 miles an hour that way to us, so it can look different. But the physical reality is there's just a differential in the arrows between things. And all you're saying is when they touch or hit or interact, they're going to exchange those arrows.
As an object falls, potential energy is converted into kinetic energy.
So bullshit.
But
there's no kinetic energy. So again, it's just a lie. Oh, damn this. I really do hate this. Which way did it go? Forward or back? Well, we try the back button.
I can't say that, like, I feel great.
Well, I really do. I hate. I mean, it's a pain in the ass to use the keyboard, but geez. Anyway, so they're doing this typical thing. So he's saying it's PE and KE, and it's really PE and MV. It's just momentum. And all you're doing is changing the momentum. Blah 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 blah. There's no KE. There's no kinetic energy. There's just motion in the form of momentum.
At the very bottom of the swing, it possesses its minimum potential energy and its maximum kinetic energy.
Its maximum momentum, velocity. Its mass never changes, so all we're saying is yes, it hits its maximum velocity. So it has its maximum momentum at the middle, and then it goes back into losing some energy to gravity, and then gravity gives it back again. Not complicated at all. But there is no KE.
As these two forms interchange again,
Just MV.
and again and again, there is conservation of energy.
Conservation of momentum.
And the total mechanical energy, which again is the sum of the
And again, you're really not conserving it, right? When the thing is swinging, it's losing all of its energy. The object has lost its arrows, and it's not really anywhere, except the idea is you're going to let it fall. And the fact is, letting it fall in gravity, it will collect the little arrows. It will collect the force differential. The force differential is real, like a wind, and now you're going to let it get blown in the wind. You're going to release it and allow it to be blown in the wind.
two is constant. This concept can be described mathematically by the following equation. If mechanical energy is the sum of kinetic energy and potential energy,
So there's no sum of, obviously, you don't really converting anything into anything here. There's no such thing as this potential energy and kinetic energy. There's just storage of energy, and you can put stuff into storage and get stuff back out of storage, and that's all there really is, and it's all just silly.
which are in turn represented by these.
So this is the bullshit again. Once again, we have the bullshit equation, no evidence, no proof this has anything to do with reality, this 1/2 mv squared. It's just mv, and we know that it's not mgh, it's mgt. The time will tell you how much energy you're going to get from gravity. It's in 1 second units, okay? The force of gravity is in seconds. It's a time-dependent force. It's not in distances. It's in seconds. It's not 9.8 meters per foot. Yeah. 9.8 meters per second per foot. Yeah.
Expressions, and this value is conserved, then 1/2 mv squared initial plus mgh initial will be equal to 1/2 mv squared final plus.
And all of that is just nothing. There's just nothing there that's real. So this is just circular mathematics. They're just showing you it's circular. Okay, it's just saying the same formula is the same formula. Just bullshit. Yeah, duh. Which is just saying, okay, the idea is an oscillator like a pendulum. Theoretically, it's always going to be continuous, and obviously the atmosphere will take all of its energy eventually. So, but if you can put it in space, it'll go a very long time.
mgh final. It shows that the sum of the kinetic and potential energies of a system, like the pendulum, will be the same at every point in its motion.
All right, so that's the silly part. I mean, it's silly in the sense that again, it's storage, it's not potential. So it's like the spring argument. In each case, every time you go a little bit this way, you're storing energy, stretching the spring, you're storing energy, compressing the spring, you're storing energy. And so it's just about how much energy you're putting into storage. There's no potential.
This equation will be used frequently in physics when we want to assess the kinetic or potential energy of an object at a particular moment.
So none of this works as soon as these masses change. So if I change the m in any of these two equations, so I'm doing a conversion, 10-pound, 16-pound bowling ball, 3-pound bowling pin. As soon as I do that conversion, all this kinetic energy stuff fails. I won't conserve the kinetic energy.
And if we have enough information about a system, we will be able to algebraically solve for some unknown. This only works when there is no friction present, but for systems like a swinging pendulum, we can use it anyway, as the force of friction will be negligible. Once again,
No, not really, but okay, whatever.
and the label of mechanical energy is just a way of categorizing energy. It distinguishes kinetic energy of motion and gravitational or elastic potential energy.
How does it do any of that? So it's just another piece of jargon you throw in saying there's some kind of mechanical energy and somehow it's both potential energy and kinetic energy, but the potential energy is really stored energy and, well, it's just too silly.
From other forms of energy, which we call non-mechanical energy. This includes things like chemical energy, thermal energy.
So obviously all those things are ways of storage. So thermal's a way of storing energy, chemical is clearly a way of storing energy, nuclear is clearly a way of storing energy, electrical is clearly batteries as a way of storing energy. So more crap. Now acoustic, that gets a little more complicated, right? You have to have like a resonator, but it's not going to store for very long.
Nuclear energy, electrical energy, acoustic energy, and more. These are also some kind of kinetic or potential energy, as they involve the motion of tiny vibrating particles, the energy stored in an atomic.
Right, so they're exactly the same thing. You draw an illustration that shows exactly the same thing. It's essentially a spring of sorts. So it's going to be doing exactly the same thing. You're storing energy based on position and condition, and that's all it is. Same thing with the nuclear, blah, blah, blah. You're putting lots of electrons and protons very close together, and now you're creating all kinds of opportunity for them to fly apart.
Nucleus, or some other form of energy associated with either motion or storage.
There you go, motion or storage, there, the end. So let's quit playing with games with all these words and just say you can store momentum in vibrations, or you can store momentum in a circle. Simple.
But they differ in nature from mechanical energy.
So there's nothing they differ about. They're still just as mechanical. It's all mechanical. There's nothing non-mechanical. It's all physics and it's all mechanical.
As we said, energy can be transformed from one form to another, but it is always conserved. A car engine.
So there's no transferring from one form to another. It's always the same form. The ultimate elemental energy is always in the form of a bit moving the speed of light, and it can stick to matter, and you're just going to say the matter can exchange the money it has. So the currency is the force. Matter can possess currency. Matter can exchange currency, and there's no V squared currency.
Converts chemical energy stored in gasoline through a series of steps to eventually produce the kinetic energy.
So again, it's a lie that this is a good example of conservation because their estimate of the fuel's energy will not equal the car's motion. So it won't work. The momentum they create will be conserved. The kinetic energy they create in the engine will not be conserved in the motion of the car.
Energy, that is the movement of the car. When we metabolize food, we are converting chemical energy within the food into the chemical energy.
So again, we're converting it into momentum. We, by moving, create objects that have momentum, and that's all we do.
Energy in ATP, which can then be used as kinetic energy to move our bodies
So
around.
again, we won't. Oh, damn it! Did it again. Fuck. Fucking goddamn. Pieces of shit, garbage, goddamn shit, fucking software. Ugh. All right, try the space bar.
If while moving around you decide to slap your hand down on a table, all that kinetic energy is transformed.
So again, it won't be kinetic energy. It'll be just momentum, and all you're going to transfer is the momentum. The ballistic pendulum proves it. 2,000 joules go in, only 1.5 joules come out in the ballistic pendulum of kinetic energy. They lose 99.94% of the kinetic energy is gone, disappeared, unfindable, untraceable in the sense that they cannot prove that it ever existed. All right, there's no experiment ever showing the ballistic pendulum collecting anything more than the momentum. It's all just nonsense, and you people fall for it because you're dupes and idiots.
Formed into thermal energy by heating up the table slightly, as well as acoustic energy, which is the sound we will hear. As we progress through,
and all of that will just equal masses moving, and all of the masses moving will be exactly what you started with.
Through the 21st century, we will continue to try to find more efficient ways to convert energy from natural sources, like solar and wind energy,
Oh, so we get this little political horse shit.
into the energy that our civilization needs to operate all of our technology. But for now, there's much more physics to discuss, so let's check comprehension.
Yeah, well, they're not discussing anything real, so they're just discussing their religious faith, their faith in this bullshit, their faith that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. All they have is faith. Their faith that it takes 25 times the fuel to spin something 5 times as fast. They have no physical evidence. They haven't even bothered to test it. Okay, because, yeah, we all know what the answer is. The answer is no, that doesn't happen. Because the kinetic energy theorem is a fable. It's religious tripe. It's nonsense. Invented, stated, but never proven. It's wishful thinking, and I don't even know why you would wish to think it. Why would you wish to believe in some fake thing called a living force, especially if you're some sort of scientist who finds, spiritual nonsense to be a bit repugnant? Why would you believe in something sold as the living force? For over 100 years, they all called it that. Joule called it the living force. Ew. That's science? No, that's crap. It's religion. And that's all this guy is selling, is religion. All right. A dumber than a flat earther religion, in the sense that it's so obviously unscientific, unproven, undemonstrated crap. And it's so easy to contradict it. His own statement about Hooke's law in the first video. Hooke's law contradicts it. The law of the lever, thousands of year-old levers telling you what equals what. A balance, a gravity balance. It tells you what equals what. And it says quite clearly, 4 pounds going 1V does not equal 1 pound going 2V. Doesn't work. All right. So that's it, yeah. I mean, you people are just so disappointing. It's just, like I said, and I didn't have much, I have so, my regard for humanity is so low. And you really didn't have to jump very high, and you couldn't even do that. You can't even jump this stupid little fucking inch. You're so feeble, so impotent, so weak, so pitifully stupid. Hundreds of billions of neurons, and you can't figure out, well, yeah, if it doesn't take 25 times the fuel to go 5 times as fast, well, I guess that shit can't be true, huh? Fuck. Pathetic.